Let's go to our first exercise from group 1. Okay, we have this one from the slide. If you look at your slide, the only thing I asked them to find is the current. So if you look at here, this is a current. Let me highlight this part. Okay, since we have 2 independent sources and 1 dependent source, then you need to have how many steps if you do have 2 independent sources? How many steps? 2. Yes, 2. Very good. So this is correct. And then, by the way, in your exam, you don't need to draw this, but this is for your own good. Yeah, not to confuse us what to do and what not to do, right? So make sure you have that 2 steps. So like this one, step 1, and then step 2. For both steps, you need to have both figure. Okay, make sure you have that 2 figures because each figure will give you marks. All right. If you look at on your left side, we turn on the voltage first. This 10 volt. Okay. So when you turn on voltage source and turn off the current source, this is open circuit. Yes, this is correct. And then dependent source, please do not touch, put it as it is. And then you should name according to whatever you have. So like this one, VX1. But where is that I1, this I, in the figure? 4, okay, 4, yeah, it's here. Okay, and this is the thing I'm going to look at. So you have that I1 there, and for this part, make sure you name this one as a I2 because the step number 2 should be I2. Okay, step number 1 should be I1. Okay, and then where is your aim? Another thing that I'm going to find is your aim. If you maybe your works here, you get it wrong here. Maybe this is wrong, and then I will look at your aim. If you write down your aim, then you get some marks. I equal to I1 plus I2 because we have 2 steps for superposition. Okay, and then if this is correct, then I give you okay. Is it okay now? Can you hear me?
Yes, madam.
Okay, alhamdulillah. All right. So far we are here. Okay. All right. Let me check. This group, they are using node analysis. Up to you. You can use from chapter 1, chapter 2, chapter 3 method to solve your problem. Okay, like this one, there's no super node. So you have 10 minus Vx1 and make sure that you know where that node coming from because there's some problem from other group. They cannot figure out which one is which one. So the whole node here, they are one single node. Okay, kenapa ni? Okay. One single node. Okay. And then tak boleh delete ke apa? Can I change? Okay. this node, there are one single node. Okay, and then this is 10 minus Vx1 divided by 20, yes. And then make sure for nodal analysis you have the current direction. Okay, and then this is 0.1 Vx1, yes, yes. Okay, and the fastest way to get your answer, because you already found your Vx from your from the video, right? Yep, that's your video. Px equal to 12.5. So that 12.5 is at here. This is 12.5. So what is your I? If you know that this is Vx and this is your I, this one is actually 12.5. This is 0. Then what is your I? And you know that resistor equal to 4 ohms. You can apply Ohm's law, right? So V equal to IR, then I equal to Vx divided by 4. So you know your Vx equal to 12.5 divided by 4. What do you get? Use your calculator. Yes, you should get the answer. Yeah. Kejap. Oh. For this group, okay, for this group, I think he or he, their group, they focus on the fastest way. Okay, actually I want to check your answer, how you get using the I value there. So this is smarter way lah to get the answer. Tapi if possible, you show me how you get this I1 and I2. This one I1 and this one I2. So that I know that you know how to get your answer. Okay. So this one you compare with the I here. Find I here and find the I over here. So you will get the answer. Okay. Right. We go to group number 2. Where's group number 2? Check. Can someone point out where's group number 2? Oh, volunteer. Where's group number 2? No, nanti I will go back. Maybe group, this one group number 1, maybe she. Group number 1, same. This one, she's also using the same VS1. So, okay, let's look at the next group. Group number 2, mana? Lah. Tak ada. Okay, group number 3. Group number 2, do you have any problem? Group number 3 also not here. What happened?
On the way.
On the way. Okay. Group number 4 then. Where's group number 4? Okay, see. Okay. Do you have any question regarding on group number 1? Question? Ada orang nak masuk. Okay. Right. Group number 1 done. Group number 4. Convert. If possible, you upload PDF file because of later on, after this, you're going to use everything in PDF file. So I don't need to convert and then process your file. Then combine everything in one single file, like the PDF file. Okay. By the way, for your quiz, you guys okay with your quiz? Do you realize something? We had the dependent source, right? This is a positive, negative in the question. Remember your question? And then they put the unknown, which is I node. And then they put this inode be exists elsewhere in the circuit, which is here. Inode. This is your quiz. Saya pun dah tak ingat quiz like this or something. But it belongs, the inode here belongs to somewhere else in the circuit, which is here. And then what do you think the answer for inode? Is it in voltage or is it in ampere? What is this unit for inode? Even though I know the name will confuse you, but this value belongs to this inode. The current flow through this resistor, I think maybe this is 6 or 9. Okay. So what do you think? Is it a voltage or is it a current for this dependent source? What is this one? Can you guess?
Voltage.
Yeah, this is a dependent voltage source, right? So it's supposed to have a volt here, not ampere. Okay, that's why you need to understand what you have from your circuit information here. Okay, so this is the answer. Okay, let's go to our group number 4. For group number 4 here, okay, we have two independent sources. So you have 2 steps. Okay, that's good. And then you have the dependent source. And if you look at your answer here, the group 4 answer, they keep the dependent source. Yes, this is correct. And then they turn on only one at a time for independent source. So let's see our step number 1, 6 amp. So let it be. And then step number 2, let it be to turn on the 30 volt. Okay. And to turn off the other, so look at the second part, you have here voltage source, right? Oh, sorry. Voltage source here. So a voltage source here, to turn off a voltage source, you should replace it with a shorted path like this. And for step number 2, to turn off a current source here, you need to replace it with a open circuit like this. This is good. So this is correct. And then we go to, okay, to this, how to solve this. All right, okay. And yeah, this is good because our group number 4, they mentioned about this one, V naught is equal to V1 plus V2. What is this one? Okay. Right. Okay, let me check your question. Group number 4 supposed to find V naught. Okay, V naught. Not this one. Okay. Because I left another one for our group number 3. Okay. Then if you look at V naught is here. So in your first information here, it's supposed to be V1, yes. And this one, V2. Because V1 here and V2 here. Okay. And then this one, our group number 4, do you apply mesh analysis or what? Mesh analysis or nodal analysis here? Nodal. Okay, nodal supposed to have what? The first thing first. You're going to set what? Yes, reference point. So where's your reference point? Yeah. Okay, reference point, and then you draw all the current direction. Yes, you have that. Very good. And then you have a point node, right? Like this one B, this is A. That's good. Okay, now KCL at V1. Where's your V1? Mana V1? This one. Where's your V1? Which one? Okay, tak apa. Node A kot. This one. KCL at node A. So this is node A. So A, the 6 amps here equal to V4 minus V4 bukan A, VA. This is VA minus 0 over 40 and VA minus VB divided by 10. Yes, this is good. And then our second part here, I need to keep on look at this one so that your friends can come in. Okay, then this one, maybe this is correct. We will check later. And then this part, you have KCL at V2. Bukan. This one should be a apa ni? I think maybe dekat sini kot. VB, right? VB. Okay. And then, so if this is a VB, then you have 0. Yes, you still have to draw this. Okay, good. Okay, and then this is, what is this part? It is negative 30. Majority of you, when I check your quiz, some of you, when you put a 0 here, reference point, and then this is a plus, right? And this is a minus. So what is this junction? The note here. This is negative 30, right? Because we have negative at this side, and supposedly we have negative 30. If you're confused, then you can draw this one like this. Then you name this one as something, and that V, this higher polarity, which is 0, minus with low in polarity, which is the Vx, equal to the value. The value is equal to 30, right? So this is 30. So Vx here is equal to negative 30. So just write the value here, this note. Do not put a Vx, okay? This one just, I want to show you what is this part, what is the note value. So this one should be negative 30. Okay, and then 0 minus VB over 40 plus 10, yes, correct. And then plus 4I2, yes, correct. And then equal to, what equal? Because this one, the current direction is in that part. Okay. And then VB minus 30. That's why you have the plus here. Then this is correct. Very good. Okay, I hope this is all correct. And then we will check with group number 3. Do you have the same answer or not? If according to our group number 4 here, the answer is equal to V naught, which is 18. But where is the I naught? I naught is at here. So you're supposed to have, if this is 18, and this is 10, and this is the I naught, then what is I naught equal to? Anyone?
1.8.
Yeah, 1.8. Coming from where? Because this is 18 volt, right? 18 divided by 10. So this is 1.8 ampere. Okay, let's look at our group number 3 answer. Where's group number 3? Not coming yet. Tak ada. Okay, we reserve that answer here.
Dah hantar madam, tapi saya dah
Ada
buat
hantar?
IO dengan VO sekali. Saya buat.
Wow. I naught is equal to berapa tadi? 1.8 ampere. And yeah, this V naught equal to tadi berapa? 18. Oh, okay, this is correct. Okay, this is done. Okay, next. Group number 5. Kalau group number 3 ada, we can check now. If not, we go to group number 5. Yes, group number 3 here. Not. Frankly not. I think my internet is too slow. Too slow. Okay. By the way, why we need superposition? Superposition in the first place. This one just to give you some idea why we need superposition. Actually, this is all about linear system, linear circuit like this. If you have something like independent sources, more than one, if you have more than one source, you can actually use superposition in order to solve for value of interest. Let's say you want to have a V node right here. So you use one method, which is we call it as a superposition, in order to find that value of interest, the V node here, you're going to turn on only one source at a time. So you can plus the V node equal to V1 plus V2 plus V3 in order to get the total of the V node that you want. Okay, but you need to separate all the figures that you have, like in our group number 5 here. Okay, so the group number 5, okay, she or he, okay, he turn on the 2 amps first and then off everything else. And you know that current source, if you want to turn off, you should open the circuit, right? So there's no more current over here. So no need to draw this, it will make you confused. So just like this is good. Okay, and then for this part, please be careful because you're going to have a V1, or if you write down like this, then this one will become V1, okay? Not V node. Or you can write down like V node 1, also can, up to you. If V node 1, then V node like this, okay? And then we look at the step number 2. You turn on the current source, the 4 amps. If you want to turn off the rest, then there's no more current over here. Yes, this is good. And then the voltage source like this. Yes. So if I mark your answer, I will mark on whatever you have here. So this is correct. And this is also correct. V2, the variable of interest here. And then the last part, you're going to turn on this and then off the rest. So this is correct. And this also correct, V3. And then look at your method to answer this because they are in parallel with, kejap. Are you using voltage divider? No, No. Okay, it's okay. But if you want to use current divider also can because you have a current flowing through here. And then you will have what? 2 into, I think you are using that current divider. So over here, it's supposed to be 10 divided by 10 plus 8 plus 5 like this. Yes, very good. And then multiply by 5 because this is Ohm's law, right? This is a current, this is a resistor. Okay. Maybe this is, the answer is correct. Okay, that's good. And then number 2, but please be careful with the positive and negative. Since this is a plus, right? So your current direction should be this way. This is correct. And it's supposed to be positive. So this is good. Okay, next, you have this. And your V2 is over here, across the 5 ohms here. Then what is your, same as before. You're going to have a current divider, which is coming from here. You need the source, that's why you have 4. And then you have an opposite resistor, which is 8. And then divide by summation of all resistor. That's why you have here. This is a current. And the current is flowing through this way. Okay, this way. So it's supposed to be a positive. That's good. And then multiply by 5. Yes. Okay. Number 3, you're going to have this. And look at the current direction again. You're going to find V3, right? So if you follow this way, then look at your positive, negative here. It's supposed to be, if you follow passive sign convention of the active source here, it's supposed to be that way. That's why your friends group here, he has the answer of negative side here. And then he used the voltage divider. This is correct. And we need the voltage source, which is here. And then 5 coming, because this is across this 5 ohms, and this is correct. And then you just plus everything in series. So this is correct. And maybe this is also correct. And then you will get the correct answer, inshallah. Okay, let's look at group number. Do we have the same answer with the other group? Check. Group 5. Oh, only one. Okay, done eh? Okay, only one group. So I cannot check with other group. Okay, this is good. Return. Let's look at our group number 6. Group number 6. Where's number 6? Not yet. Okay, tak apa. We go to group number 7. Group number 7. Okay, do you have any questions before we go to group number 7?
Madam,
Yes.
yang group number 4 tadi,
Uh-huh.
kan current 4 IO tu enter juga kan?
Like IO, group number 4 eh. This is group number 4. Okay, dekat mana? Which one? The 4 I note here.
Ya.
Okay. Alright. Kenapa? Enters. You mean which one? Brother? Okay, this part.
Dekat kan KCL kan current enter equal to current leave.
Yes.
So yang enter bukan 6A dengan 4I note ke?
Kejap. 6A. Oh, dekat sini. That step number 1 ke? The first step.
Yes.
Okay,
Yes.
step number 1. At A. So this is enter, this is leaving, and this one also leaving. Nampak ke? Tak nampak. Macam ni. This is enter. This is leaving. This is leaving.
Okay.
Maybe tak nampak ni. Yeah, okay. Let me zoom. Enter this part. Okay. And leaving this one. I1 and this one. Ada orang send me message ke? So which one confuse you, brother? Message coming from here. That's okay. So
Madam, tak gerak.
this is 6. VA minus 0 over 40, yes. And then VA minus sorry. Which one? Pink? Is it freeze my computer? Okay. Sekejap.
Bukan.
Which
You
one
can
is
see
not
what
moving?
are you showing.
It's delay.
Huh? Nanti kejap. Oh, delay. Maybe our internet connection is not good lah. Okay, now what do you see? Is it still delay? My voice, is it delay or not?
No. The voice okay.
Can you? No. Okay, only the screen, right? Okay, what about now? Kenapa delay teruk sangat hari ni? Okay, this is enters. Actually, look back at your question. This is inode. Inode is entering 10 ohms. Why enters 10 ohms? Because you follow the V node positive, right? Okay. Still delay? Kalau still delay, maybe I shall change my internet. See, aduh, mobile hotspot. Sekejap ah. Alright. Is it okay now? Brothers and sisters?
Okay.
Okay, alhamdulillah. Okay, look at the thing. You confused at this point, right? VA. At this point, right? VA here. The A here.
Yes.
Okay. This is entering according to this 6, right? And then this is a leaving, and this also leaving, right? This one you choose what the current direction you like, and then you apply that KCL. So you have 6 equal to this value. Is it clear? Or
So-
which one?
So we can choose the current enter or
Boleh. If you choose this one as the current entering, like maybe you're going to have this way, then this one no more. Because the other question they ask you to find inode, right? And the inode current direction is this way, right? If you choose the other way, meaning to say you're going to have the other current direction, but you are actually going to solve for this, right? So you want to have maybe like this, all current is entering. Okay, no problem. So you're going to have an equation like this is 6 plus, okay, 6 plus not VA, minus 6 plus, because right now you're going to have all enters. So 6 plus 0 minus VA over 40, and then plus VB minus VA divide 10 equal to 0. You need to follow passive sign convention if you want to change all the current direction. But if you do the arrangement again, you will have the same as what you have here. Okay? Is it same? Nampak tak? Ke terlampau ni? Conteng. Or is it too small? Like this?
pump.
As long you follow passive sign convention, you want to put any direction also can, no problem. Let's say this is a current direction, right? The source is going up, tapi eventually you want it to be the kejap, saya nak padam ni, kenapa dia jadi menconteng. You want it to be everything going up like this. Then the 6 here becomes negative 6 in your equation here. Okay? Because you want to have a different direction as what they have here. Okay. So our group number 3 tadi dah hantar belum? Group number 3.
Dah Afiq.
Okay. Group number 3. Let's look at group number 3.
Amali punya boleh madam.
Amali.
Mana-mana boleh.
Oh, mana? Tak nampak.
Amali.
Amali. Okay. Let's look at their answer. Answer is, because we already found this one, right? Yeah, this is correct. Okay, let's look at the stats. Okay, turn on this one. Yes, correct. This one correct. This one maintain. Good. So, this one you choose mesh analysis, right? No.
No window.
Okay, but because I saw your this. Where is it? Okay, up to you. You want to have a nodal or mesh? If you have mesh, make sure you have this. The 3 imaginary loops. So the first one, I1 is equal to 6M. I2 and I3. Okay?
Yang tu super mesh kan? Bukan
Yeah, you have a super mesh if you use the mesh analysis. Okay, tapi this one you claim that you use nodal analysis, right? So let me because when I saw something like this, I straight away say that because you have the dotted lines here, straight away I tell that this one is a mesh analysis. Because why? Because you don't have the reference point. Where is your reference point if you claim that you use nodal analysis? Yes, this one you label, then I can say, okay, still I accept as a nodal analysis. Okay, all right. Now look at your answer here. Betul tak? So you have a 6 here.
Terbalik kena.
Oh, terbalik.
VA over 40 dengan plus VA minus VB over 10 tu patutnya sebelah kanan.
Kejap. Come again. Saya tak ni. Apa yang terbalik?
Yang selepas nombor 6 dekat not A dengan not A minus not B tu sebelah kanan.
Oh, sebelah kanan. So you mean like this?
So nanti jawapan dia jadi positif. Yang 240 tu jadi positif.
Okay, this one betul. Burn down.
Ini salah. Balik.
Salah?
Sama yang VA over 40 tu.
Okay. Betul. Sometimes if you didn't put the current direction, I also can tell from your equation here. Tapi it's a little bit difficult for me lah, because you put it other direction. So this is, if I look at your answer here, this is 6. I claim this is like this, and then VA minus VB. This is your current direction. So you're supposed to have equal here, right? And then VA minus VB, because this is your current direction from this point. So this one wrong. Okay. Tapi macam mana boleh dapat dia correct answer at the end? Okay.
Dia tukar bawah.
Okay. This one, yes, correct. You turn off the current source, so there's no more current source here. Okay, and then you apply at VA. This one, okay or not? Negative up, negative here, positive here. Sebab nanti, okay. Right, so this is negative 30. And your current direction again, this way, and all enters, right? So 0 minus VA, okay, this is okay. Minus 30, okay. Okay, good. Okay, maybe this is correct. This is also correct. And then hopefully this part, you have it right here, and then you can get the answer as what you have here. Okay, so recheck your answer here, because this equation salah kan? Okay. All right. Very good. Let me return. Okay. Our class time is already up. Do you want to continue or stop here? Do you have question? Anyone?
No, madam.
No, clear? Because next time, next class, inshallah, next week will be mid semester break. And then we will have chapter 4 again, but we still have a huge syllabus to cover, because after this, you're going to have source transformation first, and then Norton and Thevenin equivalent. So that's a very huge topic. And then also we have a maximum power transfer. But maybe they will exclude that chapter. Tapi itulah. If you look at your chapter 4 slide, there's a one topic about linearity, right? That's linearity you can cancel, because we will not include in our syllabus. That's why I just go directly to superposition first for our chapter 4. But everything is about linearity. Okay, so it's actually go back to linearity, even though linearity is not in the syllabus. Macam itulah. Okay, do you have any question? Tak ada? Then we can stop here and make sure you upload your individual file so I can record as your attendance, inshallah. Okay, let us close our class today with Tasbih Kafarah and Surah Al-As. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Al-'asr innal insana lafi khusr illa alladhina amanu wa 'amilus salihati wa tawasaw bil haqqi wa tawasaw bis sabr. Alhamdulillahi Rabbil Alamin. Group 6, not yet, right?
Not yet.
Not yet. Group 2, do you have any problem? Because our other section, they discuss after the class because they have some problem. If you do have, then you can stay. The rest you can leave. Inshallah, we will discuss in the next class.
Thank you, madam.
All right. Yeah, welcome.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Sama.
Thank you, madam.
So group 2, no problem.
Thank you, madam.
Okay, welcome.
Thank you, madam.
Stop recording.